So let's give a minute for everyone to jump in to the call. Yeah, so let's start the webinar. Thank you everyone for joining. So good morning for some in the global north, or good afternoon or good evening for people joining from South Asia or Southeast Asia, for joining us for this important segment of this mountain to coastal region when it comes to early warning. On behalf of International Water Management and our organizing partners, including CGR, National Building Research Organization, Alliance of Biodiversity, CIAT, ICIMOD is an intergovernmental organization for mountain development, UNESCO, UCL, and Geohazard International. I'm really honored to welcome you to this session 6 on the Advancing Early Warning for All webinar series. It started in March 15th. This is the 6th webinar series, focus on mountain to coast strengthening early warning for landslides, GLOF, and tsunami. All these are very rapid disasters, so this really calls for global experts to join this session. So specifically, with the season now in the middle of June or early of June, we know the climate extremes are variably significantly high in many parts of the world, including South Asia. And we are talking about these topics about fragile mountains and coastal region. My colleagues will be talking more on the glacier lake outburst, on melting glaciers, intense rainfall, rising sea level. There are a lot of instrumentation, modeling you will be hearing from our experts. But what is more important is to take home message from this is a diverse group of experts who are going to highlight, what are the key challenges from the high Himalayas to the island nations in the Indian Ocean. And as I would like to also learn from all of the experts here, this conversation is not just about, timely, it is really urgent, strengthening early warning for landslides, GLOFs, and tsunami, as by 2027, every nation should have capacities to have early warning for all. So I encourage all of you to engage actively, ask questions, share your insights in the chat box, and think on how this efforts could be scaled in the countries from where you are representing. And thanks again. I will now invite the format for us is we have one main expert segment on open keynote talk that I will be introducing Dr. Asiri from the Director General of National Building Research Organization. It's very fortunate that despite his busy schedule, he is available to speak on the topics of landslide from Sri Lanka. He is a distinguished engineer and leader in disaster management. He has vast experience in geotechnical engineering and landslide mitigation. And they have established a range of early warning capabilities with field level automations to data designation. Under his leadership, NBRO has advanced the geospatial technologies and community awareness program. So without further delay, let me invite Dr. Asiri to share your screen. And you have got 10 minutes or so to introduce the topic, and then we will go to the panel session. Over to you, Dr. Asiri.
Thank you very much, Dr. Giriraj, for your kind introduction. Shall I share my screen?
Please.
Can you see it?
I can see.
Yeah. Hello, everybody. I'm Asiri Karnavardhana, Director General of National Building Research Organization, which is the mandatory organization for the landslide disaster management in Sri Lanka. So it's a great pleasure to share our experience with international crowd. So today, today, of course, this seminar is Mountain to the Move, strengthening the early warning for landslide and the tsunami. So it's in Sri Lanka, as you know, so the National Building Research Organization is the main organization for the landslide disaster management. Today, I'm going to speak about our effort to landslide disaster risk management. Especially, I'm talk about the present early warning system practice in Sri Lanka. So this is the kind of data for the landslides and the other disasters. You can see in Sri Lanka, we have the kind of disaster like landslide, flood, and strong wind and lightning. Out of that, landslide disaster caused a lot of fatalities. Of course, the flood gives a lot of infrastructure damage, but when it comes to the landslide, it gives a lot of fatalities. You can see this graph. So when there is extreme event, a lot of landslide disasters occurs, as well as number of people died due to landslide disasters. But you can see after 2018, the significant reduction of the fatalities. This is mainly the effort that we are taking to control the situation, like early warning system, then the kind of mitigation measures and the awareness program. So this is mainly this reduction of fatalities due to mainly our effort to the landslide risk reductions. So I'm going to explain this one. You can see here. So this part, in Sri Lanka, the central part is highland. So many landslides occur in this area. So you can see this is Central Highland. This is a red spot shows the where the landslide occurred so far. So out of Sri Lanka, 20% of land is prone to the landslides, and about the 30% population live in that area. So you can see how serious is the problem. So then there are some photographs I just want to show you with some to get some idea. So these are some past landslides. It damaged a lot of infrastructure as well as the some settlements. Yeah, these are the some landslide due to the man-made activities. Earlier, I show you the landslide due to the natural landslide. These are the due to the man-made activities because of the some unplanned construction. A lot of damage occurs. So these are kind of a big landslide recently occurred, 2019. You can see these are very deep-seated landslides, and the kind of finally it start from the somewhere and came as a debris flow. And this particular landslide in Miriabad, about 37 people died and 63 houses destroyed. This also Aranayaka landslide in 2017. The landslide initiation here and debris flow came down about 2 meters, 2 kilometers, and about 37 people died again here. So these are the typical landslide we observe in Sri Lanka. And these are some other landslide because we had a kind of extreme event in 2017 where a lot of people died and many landslides occurred in the southwest part of the country due to the southern monsoon seasons. And totally about, I think, 200 people died due to this extreme event. So these are some photographs. You can see the damage of the many landslides and this occurred in 2017 due to extreme events because we received about the 400 millimeter rainfall in the 6 hours time. And in Sri Lanka, of course, the main triggering factor of the landslide is the rainfall because we don't have the seismic activities here. Mainly, the landslide is due to rainfall. You can see this some extreme event. So, in this case, the cumulative rainfall caused the landslide. Here, the high intense rainfall, very high rainfall, and so here also same. So, we received about more than 400 millimeter rainfall within 6 hours or 7 hours. So that causes many landslides. So here I would like to explain what are the strategies that we adopted to reduce the landslide risk. So as I mentioned earlier, so NBRO is the focal point for the landslide disaster management. To control the situation, first we do the landslide hazard zonation mapping, and then we convert this hazard map into the risk map. And of course, we are doing the landslide special investigation to identify potential area. From this special investigation and the hazard zonation map, we identify the vulnerable communities. Then once we identify the vulnerable communities, we are trying to do the we are trying to control the risk by different methods. So in that case, the early warning and the awareness and early warning is one of the very important subject. Today, I mainly talk about that one. And of course, due to the in high risk locations, very important location, we do some mitigation measures. And sometime when the high risk families are there, so we do some resettlement program to uh, resettlement program to resettle there in the safe locations. And of course, to control the man-made activities, we do some policy changes. For example, now in the mountainous area, it is necessary to get our approval to construct the whatever the development activities in the landslide prone areas. By doing so, we try to control the man-made interference for the landslide occurrence. So, as I explained earlier, so now since once we identify the hazard areas and once we have the risk map, so we identify the risk communities. For example, now we have the database like how many buildings are in the risk area, moderate risk areas, how many buildings are in the high risk areas, how many buildings are in the low risk areas. So we have the database, and to prepare that database, we are doing kind of hazard zonation map, which is a kind of technical. This is kind of a technical research output of technical research. For that, we consider six factors like the bedrock, soil cover, slope angle, hydrology, land use management, and landform. And based on the research, we are given some weightage, and from that we develop this kind of hazard zonation map. From the hazard zonation map, we identify high hazard, moderate hazard, and low hazard, and then we convert into risk map. So from that, we got this kind of a risk portal or risk information portal, which we use for the risk reduction option. For example, giving early warning, mitigation, and awareness programs. When it comes to the early warning, so now we are using kind of automated rain gauge system, real-time automated rain gauge system to measure the real-time rainfall. From that, we have installed about 330 rain gauge at the moment in the potential landslide areas, and we plan to expand it to the 500 very soon. From these rain gauges, we got the rainfall every 10 minutes time. For every 10 minutes time, we got the rainfall, and then we have kind of threshold limits. For example, 75 millimeter per day, we give the alert. Then the 100 millimeter a day, we give the warning. And evacuation warning, maybe most of the time when it's rainfall exceed 150 millimeter per day. So we are giving this early warning, and we issue that early. NBRO is a technical agency. We issue that early warning to Disaster Management Center (DMC). And the DMC Disaster Management Center disseminate this early warning to the general public and the relevant stakeholder. That is the current practice of early warning issuing in Sri Lanka. And this is a kind of automated system. So you can see this kind of dashboard. So where we can see which location, which location, sorry, yeah, which location rain is experienced now, and this give very detailed data. I mean the data. So even when there is a malfunctioning of the rain gauge, so it shows the this rain gauge is not functioning. So we can get this kind of data. Finally, once we have this kind of data, we have a kind of model, and from this model, with the hazard zonation map, we develop this early warning system, and this is the kind of message that we send to the disaster management center indicating the hazard level of the situation. And then, of course, we have some site-specific early warning for some critical location, like where we identify the critical location, critical infrastructure located, like a hospital and schools. So we have a kind of site-specific early warning system where we install some kind of instrumentation like extensometer, inclinometer, and the piezometers and water level meters. From that, we get some information, and then we have the alarm system to alert the people surrounding. From that, they can aware the situation of the landslide risk level. And these are some typical photographs. So where you can see the instrumentation orientation and the system. This is a kind of on-site system as well as the remote system. So where the surrounding people also can get, and of course our early warning system, early warning center can also receive this message. So this is a kind of system that we are adapting for the location where the critical infrastructure is located at the landslide prone areas. And these are some figures just I want to share with you to show that these instrumentations. So this is readings of the extensiometer and inclinometer. From that we have calculated some threshold limits. From that we give the early warning. So not only that, then we have some community-based early warning program. Of course, one program we conduct for the child center disaster risk management program for the school children. Another one is the community-based early warning program for the communities. So these two activities we are carrying out with the Education Ministry as well as the Divisional Secretariat and the local level administrators to aware the people. And for that, of course, we use kind of manual rain gauges, and we distribute manual rain gauges, and we aware them how to use this one. And this is a kind of one workshop we are carrying out for them. So we have the alert limit, and the people also prepare the kind of risk map in the village level, and evacuation route and everything is prepared in this kind of program. And this is the kind of dashboard because we give some kind of linkage to these people when there is a rain. So this will automatically they give the message to our early warning center by I mean the kind of telephone call or like something. So then we update this one. And now we are trying to use some kind of semi-automatic train gauge system to enhance this system. These are typical locations and typical dashboard you can see for this kind of community-based rainfall monitoring system, because sometimes because of the extreme weather condition, so it's very difficult to control the system only with the automated rain gauge. Especially this approach we use where we identify the high-risk communities. Still, they have not been settled in the safe location. Until they settle in the safe location, we use this kind of approach to safeguard them during the rain period. Then I just want to share some experience with some kind of advanced method to develop early warning system for the rapid lone travel in landslide in Sri Lanka. This research we carried out under kind of Japanese universities where we try to predict kind of give the early warning for the occurrence of rapid lone travel in landslides. This is we carried out after this Aranayaka landslide. In that research, we tried to predict the rainfall one day ahead with some kind of meteorological model. And from that model, we try to simulate the kind of ground condition. And from that, we try to calculate the critical pore water pressure, which caused the landslide in particular area. And then using the kind of augmented reality methods, we try to share this with the community. So this research now we have already carried out to 2 or 3 locations, and this is in progress. And this is a kind of output of that research. So we calculate the critical rainfall, and from the critical rainfall, we carry out this kind of slope stability slide model. And from that, we can identify the landslide initiation as well as the deposition areas and alert the people which rainfall this can be activated. So this research is ongoing, and we want to continue that on the rest of the areas. And then finally, I just want to share some of our experience with the landslide mitigations, because now we have identified many locations or many critical infrastructure located in the landslide location. Those locations we do kind of this kind of structural mitigation. For that, NBRO is capable of doing investigation, design, as countermeasures. So this is one location. Now recently we carry out mitigation. This is the road to the Adams Peak, famous secret locations. So we carry out this kind of mitigation. So this is there's I think another location. This some of the town in the Ratnapura area. It was initially planned to relocate to this landslide, but now after our investigation and the government investing money, then we re-strengthened or re-stabilized the slopes, and now this is a safe place.
We can wrap up. Good.
So then
Dr. Asri.
Yeah, last slide. Yeah. This is the kind of concept that we are adapting to the relocate the safe people, relocate the landslide victims. So we adapt kind of disaster resilient concept. So not because we realize that most of the time this resettlement process is unsuccess because of the social issues. We try to address these social issues as well as we try to adopt this resilient housing concept where we can assure that their settlement is in the long run. And this is the kind of photograph that we show for the landslide resettlement villages. Yeah, that's thank you. Thank you for the time. Yeah.
Thank you, Dr. Asri. I think it's a justifiable keynote talk, I would say, because you have really provided a comprehensive landslide early warning, early action, and the mitigation focus by also bringing the focus of technology and how societal impact can be far-reaching resilience through the engineering part as well as the showing the early warning capability, what you highlighted. So there will be questions that from the participants can highlight more Q&A if you have for Dr. Asri. Use the Q&A segment to ask the questions. Dr. Asri, if it would be good to see the Q&A and you can respond to that. Now, let me move on to the expert session that is will be moderated by Anastasia. So if I just briefly introduce before she take over, she is a research team leader for the Alliance Biodiversity and SEERT. It's also the sister organization of the CGIR, and she leads and manages the various geospatial tools projects specifically, but more looking at the data knowledge products into the broader environmental and the development initiatives. She also leads actively various early warning verticals in the organization and also focus on climate services. Prior joining Alliance, she was with the Survey Eastern and Southern Africa, like the one we had in Survey Mekong, Survey Himalaya. So it's a very right choice to have her for this moderation session. So over to you, Anastasia.
Thank you very much.
Yeah, thank you.
Thank you very much. And I think as we continue to look at the issues that affect all our communities, we do recognize that the Hindu Kush Himalaya is very mountainous, and I think that's why we are talking about the mountains, from the mountains to the oceans. So in this session, we are going to join the global experts and try to discover some of the integrated approaches that they're using for building resilience from the Himalayas and to other island nations. So we have 4 experts in this session. I'm going to introduce them first before we get to ask them questions. So we have, and I think they can just wave to the audience as I introduce them. We have Dr. Baiz Ahmed. Kindly wave to us. I'm sure your camera is on. Okay. So Dr. Ahmed is an associate professor at the Institute for Risk and Disaster Reduction at the University College London. And he holds a PhD in disaster risk reduction from the same university and also leads the UCL International Displacement Monitoring Center Disaster Displacement Research Hub. So very appropriate for this session. And he also teaches courses on GIS and remote sensing, in addition to doing other university-related activities such as guiding and supervising PhD and MSc students. He's also a visiting lecturer at the University of Dhaka and a fellow of the Royal Geographical Society and an editor for the International Journal of Disaster Risk Reduction. You're most welcome, Dr. Ahmed. We will also have Dr. Hari Kumar. Kindly wave to us. Thank you very much. Dr. Kumar is a civil engineer with more than 30 years of experience in disaster risk management and earthquake risk reduction. He's also a regional coordinator for South Asia at Geohazards International in Delhi, India. And he has led key projects like the Delhi Earthquake Safety Initiative and also serves in India's National Disaster Management Authority, in addition to other very expert specialties. Welcome, Dr. Kumar. We also have Dr. Finu Shreta. Kindly wave to us. Yeah, thank you. So Dr. Shredha is a remote sensing and geoinformation analyst at the International Center for Integrated Mountain Development, that's ICIMOD, based in Kathmandu, Nepal, with over a decade of experience in cryosphere research and also specializing in glaciers and glacial lakes. And one of the areas we are looking at today, the glacial lake outburst floods in the Hindu Kush Himalaya region. She holds an MSc in hydrology and meteorology from the Tribhuvan University in Nepal and has contributed to many research efforts in her career. Welcome, Dr. Shredha. And last but not least, we have Dr. Srinivasa Kumar Tumalan. Kindly wave to us if you're still online, and I hope you, as you speak, I would request that we put our cameras on so that the audience can see us. Dr. Kumar is a leading expert in tsunami early warning systems and ocean observation. He serves as the head of Intergovernmental Coordination Group for the Indian Ocean Tsunami Warning and Mitigation Systems Secretariat at UNESCO's Intergovernmental Oceanographic Commission based in Perth, Australia. He has over 25 years of experience and held key roles in the Indian National Center for Information Services and the Indian Space Research Organization and also the UNESCO IOC. So welcome our panelists. And as Dr. Armanath had indicated, we will take at least 3 minutes each for each of the questions. And as we dive into understanding this area, and I hope you'll try to keep it brief. And for our audience, if there's anything that you feel needs to be followed further, I would kindly request that you put it in the Q&A section. And also the panelists, if you get a minute and find a question that's relevant to your area or to the question, you're kindly welcome to answer it in the Q&A section. Otherwise, we'll have a short section at the end. All right, so my first question goes to Dr. Ahmed. How can advances in geospatial data and machine learning improve landslide and the glacial lakes outburst flood forecasting in data-scarce mountain environments? And as you answer that, kindly share in examples from your work in the Hindu Kush Himalaya or other similar regions. Welcome.
Sorry, it's for me?
Dr. Ahmed, Dr. Ahmed, yes. Is he still online?
Don't see he is there, but why don't you move to the second part of the panel? He was there, but I don't see him now.
Yeah, he seems to have dropped off. Okay, I think as we wait for him to come back and answer that question, I can go on to Dr. Kumar from Geohazard International. And you have worked extensively in northeastern Himalayan region in Kerala, where complex terrain and rapid urbanization and climate-induced weather extremes intersect. Kindly give us some reflections on what would be the crucial first steps before launching early warning mitigation actions and early warning preparedness actions that include early warning systems. Welcome, Dr. Kumar.
Thank you, Anastasia. I hope you can hear me well.
Yes, you're audible.
Thank you. Thank you for that question. It is, I think, very important that we reflect on what should be the first steps. Many a time we jump into mitigation and preparedness, but there are some before we even begin talking about early warning systems or preparedness or mitigation, one of the most important things we have learned, especially from our work in northeastern Himalayas and also in other parts of South Asia, is that we need to understand the risk, really understand the risk. Many a time we believe we understand the risk, but we don't understand it fully. Landslides are not uniform. I'm talking about landslides here. and they are actually shaped by local geology, slope stability, the drainage, the rainfall, construction practices, as was alluded to before. What kind of construction practices are affecting our landslides? And increasingly, of course, by extreme weather events linked to climate change. So in any place we work, we cannot assume that a solution that has worked somewhere else will apply here. We need good hazard mapping, site-specific assessments, and an understanding of what is triggering these landslides. And in many parts of South Asia, I see that the landslide hazard maps, especially, are 1:50,000 scale. Those are useless for risk reduction. In a city we worked in, Aizawl, they progressed from 1:50,000 to 1:10,000 to 1:5,000 in a matter of about 6 years. But now they are aiming for 1:1,000 because they believe that it is required. That level of detail is required for enforcing any kind of regulation. That is one part, understanding the risk. The other part is understanding the community. We are trying to protect a community without really understanding them. So who are living in these vulnerable areas? Who are the leaders? How do they receive information that they trust? What are the barriers they are facing in actually preventing landslides? It is very important to understand the community and how it works before we plan for preparedness and mitigation, because we should cater it for the community and their behavior. It's very, very important. And then the last I would think is that we need to understand the stakeholders. Who are we going to work with? We have to get a clear picture of which agencies or departments are responsible for what, who handles land use, who maintains the infrastructure, who assesses the building sites before any kind of construction happens, and do they have the capacities to actually assess them, and are there enough number of these people who are available to the municipalities for doing the assessments? Because unless we are clear on who does what, when, and how, even the best technical recommendations may not be taken forward. So in short, it's about grounding our actions, whether it be mitigation or early warning systems or preparedness, grounding our actions in a deep understanding of the physical risk, the social context, and also the institutional landscape. Because if you don't take time for that, there's a risk that our interventions may not be relevant, or sometimes could lead to unintended consequences. Thank you.
Thank you very much. I think that gives us a very good overview of the fact that we don't just dive into activities without having a clear understanding of where we are going and why and how. Yeah, thank you very much. We'll come back for a follow-up, but first we go to Dr. Finu Shretha from ICIMOD. ICIMOD has developed innovative tools for GLOF, that's the glacial lakes outburst flooding monitoring in the Himalayas. How are these tools improving preparedness on the ground, and what are the biggest implementation challenges in high altitude settings?
Okay, thank you for the question. So ICIMOD has been instrumental in advancing GLOF monitoring in the regions by leveraging scientific expertise and fostering regional collaborations. In partnership with the region, ICIMOD has developed GLOF database, which is an interactive platforms. And from that platform, everyone can understand the GLOF events. It's like the event dates, locations, triggering factors, and also the reported impacts, such as the damages to the settlements, infrastructures like hydropowers, right, and fatalities, and also the livestock losses and displacement population. So through these interactions, it has given a platforms to understand the ongoing and as well as the historical GLOF events in the SKS, and also helps to understand the evolution of the risks associated with it. And ICMOD also developed a robust and regionally harmonized methodology that helps to identify hazardous glacier lakes in the regions using multi-criteria analysis incorporating geospatial tools. So these tools has been applied on the ground as well. So that helps to prioritize the most hazardous glacier lakes. So for instance, it has helped countries like Nepal and the Bhutan in narrowing down from hundreds of glacier lakes into a smaller subset that helps to prioritize that lakes for detailed field assessment and as well as like monitoring, risk monitorings. And ICMOD has been providing technical supports to the regional member countries in the lake that has been considered as a hazardous. So one example is Nepal. In Nepal, our most priority like high risk lakes, Imja Lake. So the technical expertise has been provided to them, such as in hydrodynamic modeling and the detailed hazard assessments. And using this information, it has been very useful to support in decision making, from setting up early warning systems to the planning like control the lake lowering mitigations, as well as providing the awareness and educations to the vulnerable communities as well as other downstream communities regarding what is happening in the upstreams, the glacier lakes in the upstreams in their area, and also provide them with the evacuations plannings. If anything happens, how they should prioritize themselves as a concern of the safety. So despite these advantages, like there are many challenges that has been here, like putting the system in higher elevation is many times challenges, and because of the rugged terrains and the extreme weather conditions, limited road access, as well as logistical constraint, also it's very difficult to install and maintain the system there. And sometimes the power cuts and the poor communication networks that should be related to the vulnerable peoples is still the challenges. And also the installation of early warning systems to the most priority glacier lakes also limits because of proper or sufficient fundings. So despite these challenges and also not only of the advanced technology, we should also have, like, to overcome these challenges, we should focus on inclusive governance and proper funding, and as well as strong involvement of community as well as the regions in the transboundary to mitigate the risks from the potential lakes. Thank you.
Thank you. Thank you. I think we'll follow up further on that area because we still have another round, but thank you very much. I think it's good to understand the extensive work you're doing. My next question goes to Dr. Srinivasa Tumala from UNESCO. And tsunamis remain a low frequency but very high impact risk. What are the key advancements in regional tsunami early warning in the Indian Ocean after the 2004 tsunami? Welcome.
Yeah, thank you very much, Anastasia. And then I also thank Dr. Giriraj and IWMI for having me and UNESCO on this important panel. So as if we've actually just completed around 20 years after the tsunami, the large 2004 Indian Ocean tsunami, which happened on December 26, 2004. Almost 230,000 people lost their lives in that particular event in several countries in the region, with major losses coming from Indonesia, like for example, Sri Lanka, Thailand, India. And then the tsunami waves went as far as the coast of East Africa, where lives were lost in Tanzania, Somalia. So what I'm trying to say is, this tsunami is a truly, it's a short fuse, high impact hazard, like you rightly said. And then because of the nature of, where the trigger could be, like for example, the trigger was in Banda Aceh, but then the impact was felt in the east coast of Africa, even in the east coast of Africa so far. So it's a truly transboundary hazard. And then we need actually multilateral cooperation, countries in the region, outside the region, working together. So after that tsunami, UNESCO Intergovernmental Oceanographic Commission was given the responsibility, the mandate by the UN, to set up a warning system in the region. 20 years down the line, I could say that we have a very mature tsunami early warning and mitigation system operating in the Indian Ocean region. Not only in the Indian Ocean region, but also there are similar systems operating now, coordinated by the UNESCO IOC in the Pacific, in the Northeast Atlantic and Mediterranean, and also in the Caribbean. So these systems work as a system of systems, regional system of systems, creating a global coverage of provision of early warning information for countries that are threatened by a tsunami threat anywhere in the global coastal areas. So that said, so how this system works, like I'm glad that I'm speaking after the other speakers, Dr. Kumar mentioned, and then Dr. Shrestha mentioned about how important it is to do hazard and risk assessments. That's where it starts with. So, for example, for the Indian Ocean region, the hazard comes from the Sunda subduction zone, or it could come from the Makran subduction zone north of the Arabian Sea. So making those hazard assessments, coming up with guidelines, developing hazard maps is something that has been done. And then there are also warning, sensor networks that have been established, the seismic networks, the sea level networks, tsunami buoys, which all actually are set up by member states. And then they actually transmit data in real time, detect tsunami, detect earthquakes or large, water level changes. Dr. Asiri also spoke about the landslide early warnings. Is exactly how the system works with different kinds of sensors. And then most importantly, there are 3 tsunami service providers in the Indian Ocean region, India, Australia, and Indonesia, providing tsunami warning information to countries within the region, like Sri Lanka. The Disaster Management Center receives these warnings, and the Met Agency receives these warnings, and then they actually have the sovereign responsibility to use this information, generate warnings, and disseminate to their coastal populations. Of course, I'll conclude with a small statement saying that the best warning will be useless if people can't receive it in time, the public, if they don't understand what the warning is and then how to respond appropriately. So the UNESCO IOC has also come up with a program called UNESCO IOC Tsunami Ready, which is a community-centered, user-centered program, which actually involves developing 12 indicators, how to receive the warnings, developing evacuation maps, developing evacuation routes, drills in the communities, and then talking about tsunamis within schools and so on and so forth. So this is an end-to-end system, I would say, which actually works with the member states within the region, with multilateral organizations, and then delivers warnings to the people. Thank you.
Thank you very much. I'll go back to Dr. Hari Kumar for a follow-up question. The persistent challenges in landslide disaster risk reduction usually fragmented efforts of different institutions. They seem to work in silos, but based on your experience in the mountainous regions, how do you bring them together, bring the diverse stakeholders that co-develop and implement these landslide disaster risk reductions? What strategies of bringing the stakeholders together have you experienced or do you use?
Thank you, Anastasia. That's a big challenge, and it is not only in mountainous areas. The engineers don't talk to the architects. The engineers don't talk to the architects. Architects don't talk to the geologists. Nobody talks to the planners, and they all work in their own silos. And they're all working hard on landslide risk reduction, but they are doing it in isolation. One department may be working on drainage improvements, another on building regulations, but they're all in their silos, and each of these efforts may be valuable, but they don't align, and sometimes it doesn't add up. So that we have seen it, and that is where I think my answer to the initial question was important. That understanding who the stakeholders are is very important. Understanding of the community and the stakeholders. If you know that for a start, it becomes easier to make the case for bringing them together around a common table. And this is exactly what happened in Aizawl, where Aizawl is the capital of Mizoram, is a northeast Indian state, and where after several years of working with the city, we understood that we need to bring in more players together, because otherwise the conversations are not just happening. So we formed what is called a landslide policy committee. And we brought in the public works department, the disaster management department, the municipality themselves, the water supply department. Initially it was important for them to understand that they had a stake in this, and they have to work together. So we brought together geologists, engineers, planners, and community leaders, university, local government officials, and it was not a coordination body. It became the core group, and they all felt very important, which is also important, that you need to make them all feel that their role is important in driving long-term risk reduction in the city. And that committee, they set clear practical targets. They developed what is called a roadmap to stability, and that, I think, is very important. Getting these people is one thing, but for them to together prepare a long-term risk reduction plan, which they all attest to, I think that is very important. So in many of our cities, we try to get this long-term, and this long-term for many officials means 2 years, because their term ends in 2 years. Risk reduction doesn't happen in 2 years or 10 years. So we need to look beyond, and sometimes it has to be forced, but we try to get them to think really long term together, and develop this kind of a long term risk reduction plan. It's not easy, because different institutions have different mandates, their priorities are different, their constraints are different, but it is a shared understanding of the urgency of the problem. And also it's very important to use any triggering event. Even if a small landslide happens somewhere else, we bring it up and say, this is what, it happened somewhere else, tomorrow it can happen to us. It's very, very important. That committee, it is into its, I think it is nearly 10 years old now, and they continue to push forward on their targets because it's not a quick fix, but it is slow, and there needs to be people who are driving it, this multi-stakeholder collaboration. That it's very important. Ultimately, we found that when people come together with a shared understanding of the risk and a common vision for their community's safety, they feel that it is for them, their own families, their own community, then the silos start to break down, and that is when you can get real lasting change.
Thank you very much. And I noticed that Dr. Baez is back, and I kindly request we keep it brief. We have very few minutes remaining. Sorry, Dr. Baez, I'm trying to combine your two questions because you're already in the second round. We recognize that you use a lot of geospatial data for forecasting the glacial lakes outburst flooding. And maybe you just give us an example of how you do that in the data scarce mountain environments. And at the same time, maybe highlight what's the biggest gap in translating the scientific hazard assessments into actionable early warning for decision makers. And please, let's keep it brief. I think a minute, and I know I'll give you 2 minutes because I'm combining two. Welcome.
Yes, I'm so sorry. In my office room, there was a fire alarm, very serious one, and we had to immediately leave. So the fire marshal was knocking my door. Sorry for that. I just want to quickly highlight, thank you for the question. Like of course, our system is not so advanced like the NBRO and Sri Lanka one. Bangladesh is mostly famous for flooding and cyclone, but we do have some landslides, and at UCL and working with partners and Bangladesh Meteorological Department, we have introduced our first dashboard for a district called Cox's Bazar, where we are also hosting 1.2 million Rohingya refugees from Myanmar. I just want to give you, this is the Bangladesh Meteorological Department website, where we can see what will be the amount of rainfall in the next 5 days, and based on that, it is 100 millimeter of rainfall. And we have an alert system, you can subscribe to that. So if it is between, so you will get the first level of alert because it is within the range of 95 to 220 millimeter. And this is the district. You have different level of scenarios based on risk map, but we also have inventories. Like, let's say you're getting the alert, like the BMD is getting the alert now, the alert email they are getting, and also the SMS. And one good thing is then from here, we have categorized different areas, like where do you take what type of evacuation planning and action. So we have 3 different of levels. Red point is high risk area, where is the location, blue is medium, and green is low risk. And so when you get alert, you also know where are the locations for intervention. So I mean, we used significantly machine learning and other statistical methods. Yes.
Sorry to interrupt. If you could summarize for us, so that because you only have 10 minutes left.
Okay, that's it.
Yeah, just give us maybe the key areas of the website, 1 or 2, and maybe one of the biggest gaps that you have in making this actionable for decision makers. Thank you.
Yes, so lastly, of course, we know there are 4 pillars for early warning, but this is the pillar 2, where is the detection and forecasting. But to be honest, we are now struggling to convey the message to the communities because it is highly exposed area, 1.2 million refugees who cannot move actually from their camps, and also local communities, they do not want to evacuate because they live on, like there are many different socio-economic and cultural aspects involved there. Like they live, I mean, their house is not, they don't have the land right, okay? They don't own the land or the house they build there. That's why really we are struggling currently. Yes, we have a forecasting system. It gives you 5 days in advance the alert, but we are struggling with evacuation, with dissemination among the people. Even you disseminate, they don't take the action. So probably in the other 2 pillars, communication and dissemination, and also networking, there we are giving more emphasis right now. Thank you so much, and sorry for all this. Yeah.
No, thank you, and we are sorry about the alarm that disrupted the webinar. So very quickly, 1 minute to Dr. Shreza from ICIMOD. Kindly let us know or give us some insights into how regional cooperation can accelerate sharing of early warning data and models, given the cross-boundary, the transboundary nature of the Himalayas region. In a minute, thank you.
Yeah. So sharing the information about the risks is always challenges because glacial lakes and the river system often flow across these regions. But regional cooperations plays a very vital role in accelerating the data sharing. And there are many challenges in operating real-time data sharing and early warning communications across borders because of the differences in technical standard, institutional mandates, and data sharing policies. And as well as fragile geopolitical dynamics in the regions also complicates trust and transparency. So to overcome these barriers, ICIMOD advocates for formal data sharing protocols, regional agreements, and establishment of joint monitoring stations in transboundary basin. And through platforms such as HKH, CryHop, and HKH Disaster Risk Reductions Network, ICIMOD has facilitated regular dialogues, data sharings, and joint research among the countries in the regions. And also, ICIMOD has been working closely with the partners across the regions to promote collaborative approaches and support harmonized data sharing. So these efforts have built a trust and also foster a common interest between the partners to understand the cryosphere severe risks, so that they can have more coordinations and more timely responses if need to face the GLOF threats. So ICIMOD also organizes the joint training programs and workshops, and also exchange visits for national disaster management authorities and other relevant institutions. And these activities have been very crucial for sharing best practices, as well as building the collective capacities in addressing disaster management, as well as early warning system implementations. Yeah. Thank you.
Thank you. Thank you so much. I think I'll give a minute to Dr. Tumala, and in his first the first round he did highlight efforts that are already underway in terms of strengthening the tsunami early warning systems and mitigation systems. Maybe just one final remark on how all these efforts can be leveraged to achieve multi-hazard early warning capability for other sea level related hazards.
Yeah, thank you. So I'll be very brief. So the tsunami warning system, like I mentioned before, it works across all the 4 pillars, and then it's a nice example of how technology and then community-centric actions can lead to an end-to-end early warning. Now, this can really be leveraged for other hazards in the sense that, like for example, other ocean hazards, like say for example sea level rise. You pretty much use tide gauges which are used to detect sea level. Even for a tsunami, you need tide gauges. For sea level rise, you need tide gauges, or other things like storm surges, say for example. So what I'm trying to say is you can actually leverage the observational systems, you can leverage the modeling systems, you can leverage data. Like for example, when you're collecting, for example, coastal hazard, you need a lot of bathymetry data and topography data from modeling. So you can actually use these data sets. You can actually, more importantly, build community preparedness, like I mentioned earlier about tsunami ready. And then if a community is really ready to meet a tsunami threat or to face a tsunami threat, and then they have actually achieved all those 12 indicators that I mentioned before. They understand their hazards from multiple perspectives from sea level. They have dissemination systems to receive information, and they know where to go. They have evacuation maps and so on and so forth. So if they're prepared for a short fuse hazard such as tsunami, they can pretty much enhance their preparedness for any other coastal hazard that can be oceanogenic or coastal hazard. So that can actually make it very multi-hazard kind of thing. So it can contribute to the early warning for all and all of those international initiatives. I'll stop there. Thank you.
Thank you very much. I think in a very short time, we have learned so much. The mountain regions and the oceans, I think, are not common to everyone. And in a way, they may be having a lot of disasters and hazards. I think those of us who don't live close to the oceans, we hear these things, but we also have our own hazards. So the issue of multi-hazard disaster risk reduction and mitigation is so wholesome, and good to learn that similar efforts, maybe using different strategies, different data, as we have heard from ICIMOD and models, and how to understand the base of the beneficiaries, the stakeholders who are all working there, I think has been very informative. So thank you all. We just have, I think you have tried all to answer all the questions that were in the Q&A, which is accessible to everyone. So because we don't have much time, I think we will not ask any specific ones. And I'll take it back to Dr. Armanath to conclude and give us the next steps. Thank you all for participating.
Thank you, Anastasia, for nicely moderating, and I think we have got quite a good reflection across all the 3 hazards. And of course, time is a big factor. Like Baez was mentioning about sudden early warning. This is where this sessions is all about. How do we be prepared to respond to crises like what we are organizing today? I think the main takeaway for me, I think it's a lot of message that is bringing better science coupled with local knowledge and the digital innovations that were spoken by across the experts and the keynote speak. But what I also increasingly seeing is the stronger coordination across the institution, across the borders that are very, very critical. Like we saw what happened in 2004 tsunami. It's about international borders and how countries have to coordinate and collaborate. We do see the risk of each of those hazards are quite different from mountains to coastal zone. But they are some are flash floods, some are tsunami. But at the end of the day, we need to really have critical capabilities need to be put in place in the country. So I really find it that this session is quite, promising for the participants who have joined today. We will be posting the recordings in our website, which I shared earlier, and also do watchful on the next webinar that will happen on July 15th. So I'll stop here. Thank you again for everyone for joining, and have a good day. See you all